Hey guys, let's take a look at the exponential key on our calculator. So we're going to actually use the calculator today. Yours might be a little different than mine, but you can at least use the one on your computer, which is here. If you just put CALC calculator, it'll be there, all right? And this is how you do it, at least on the calculator on your Microsoft computer, on an office computer. So they'll say evaluate 1.06 to the 8th power using a calculator. Now if you get stuck, you can always just go ahead and push 1.06 times 1.06 and hit equal, and then do it, that's the second power. Then do put equal again, third power, equal again, fourth power, and keep going. That's too tedious. So here's what you want to do. You want to put 1.06, all right? And there's a button right here. It's x to the y power. They're assuming you've already put the x in, which you have, that's 1.06. To the y power, you just click on this, then you choose what the power is going to be. You see right here, they're waiting for you. What power do you want to put this to? To the 8th power equals, bam, 1.59 approximately, okay? So that's your answer. That's how you do the calculator. You will use this, we'll do it in a second here, you'll use this to find the kind of exponential growth problems that we're going to do in a couple of minutes. Now these look super complicated, but don't let it get you down. You're just pushing buttons on a calculator and learning a few formulas, and you're copying the formula type and applying it to every type of problem that you'll have. And you might not have these down 100% by the end of the year. It's okay. You've got some exposure to it, so don't worry about it. Okay. All right. So let's say here's a good one. Jimmy has 150 delicious rabbits. If the number of rabbits doubled every year, as rabbits tend to do, he would have 300 rabbits at the end of the 1 year, 600 at the end of 2 years, and so on. Okay, so let's look at how this is written. And it's, again, this looks complicated as it has exponents and subscripted variables and all that kind of stuff. So R sub 0 means that's the number of rabbits you had at year 0, at the very beginning. That's 150, okay? So another way you can write that is you can say that's 150 times 2 to the 0 power. In other words, we're using the number 2 because it matches this. They doubled, okay? If they tripled, it'd be a 3. If they had increased by, 20%, we'd say times, 1.2. If it increased by 50%, we'd say times 1.5, and so on, okay? So that's how we do it. 2 to the 0 power, of course, is just 1. So 150 times 1 is just 150, okay? Here's the end of the first year. They double, right? And the way we get 300 was it's 150 times 2 to the first power. And of course, you won't be surprised to learn, year 2, 600, 150 times 2 to the second power, and you can just keep going and so on, blah, blah, like that, okay? Well, at some point in the past, somebody figured out this formula and went, well, this is pretty neat. We can use this. We can just plop numbers in here. Here's the formula. So that's what we're going to do. So they will say things like the end of t years, which whatever number that could be, doesn't matter. R sub t, just like all the rest of these, is 150 times 2 to the power, whatever that happens to be, okay? And you're going to want to be able to plop it into your calculator by using those buttons, so it saves you a lot of time. This is really actually neat. I mean, you could figure out if Jimmy has 150 rabbits at the end of 78 years, how many rabbits would he have? And, assuming they're not killed by wolverines or something, you'd be able to tell how many rabbits there were. So very interesting concept here. So that's kind of what the graph looks like. That's your exponential growth. Now visualize what that means, exponential growth. Exponential growth means we're not just going like this, we're going, oh, nice and steady like that or whatever. No way. As the years go by, we're going boom like that. Okay, it's just taken off. The growth is getting faster and faster. And the reason is because look at this. The first year you went up by 300. The second year up by 150. The second year up by 300. Then by 600. Then now it's going to keep going like that really high. Okay, so that's the actual formula. You don't have to write that down exactly, but just be familiar with it. We're going to use that kind of same formula. So whatever year that is, the number of rabbits is going to be R sub 0. That's the rabbit you had at year 0. Okay. The y is going to be the multiplier. Like if they say it doubled, then the y will be a 2. The t is going to be how many years later or how many time periods. It could be weeks, it could be hours, it could be months, whatever they do this. Because things like bacteria grow disgustingly fast. So it could be hours or minutes or whatever. Okay. This is another way to write it. Don't worry about it. We'll do a couple of these in just a minute. That's your answer that you're looking for. Okay, that's the amount you started with. That's at, you know, the rabbit's at year 0. In other words, we're starting now. We're at 0. Okay. Y is the growth multiplier, like we said. That can be tripled. That can be doubled. That could be, you know, again, if it's they increased by 15%, that would be the multiply, or your growth multiplier would be 1.15. If they said, it increased by 33%, you'd say that's going to be 1.33 each time. So there you go. Okay, and that's the number of years or months or whatever. Okay, let's do a practical example. The number of bacteria on the face mask tripled every month. If there were 2,500 bacteria at first, how many bacteria were there in 10 months? Nice. Okay. So let's take a look at this, all right? So our formula, we'll just say bacteria. The bacteria at whatever year we're looking for is going to be the same thing as the number of bacteria at 0, at the first starting point, which is 2,500. The Y will be, what's that going to be? You tell me. That's the multiplier. Based on this problem, what's the multiplier going to be? It's that, right? So we know what number that's going to be 3. Okay. So the T will be what? That's the time that goes by. That's going to be to 10, right? That's 10 months. Okay. So here we go. All right. That's what we're looking for. B sub T. The B sub 0 is going to be 2,500, right? That's what we're starting with. All right. The Y sub T is going to be, it's tripling. And after 10 months, that's what you're going to do. There we go. So that's how we're going to figure that out. So let's take a look. All right. In our calculator, the way we're going to do this is this. We're going to say 3, and we're going to go ahead and push this button, x to the y power. Boom. All right. Now we're going to, you can see it's waiting for us. To what power do you want this by? We want to the 10th power. Okay. 3 to the 10th power is 59,049. Now we're going to multiply that by, you know, B sub 0 is 2,500 times Y sub T. Those get multiplied. So times 2,500, and that's how many bacteria. It doesn't look right. 59,059 times 2,500. Okay, that's what it looks right. Okay, so 147 million juicy bacteria crawling all over you inside of your face and on your mask after 10 months. That's just a made up number, but anyway, okay, just think about that when you go to bed at night. That's a lot of bacteria. Okay, so there we go. That's how you figure it out. All right, let's try another one. This is based on banking. Albert Einstein once said that the compound interest was one of the great mysteries of the universe. Okay, let's look at an example of that. James deposited $500 at 7% interest, compounded annually. In other words, he has $500 the first month or year, and after 1 year, it earns 7%. Then the next, of course, he just leaves it there. Then the next year, it earns 7% on what it has already earned, and then it keeps going and just keeps earning and earning. So each year, you're multiplying it by 1.07. But I don't want to do that 100 times. So let's look at our formula, how we do that. How much money is he going to have after 14 years? He just had 500, all right? How much interest did he earn? Okay, that's the formula. Okay, and that's the amount. Let's say the amount at 0, year 0, is going to be 500. Okay, our A sub T we don't know. It's going to be the amount at year 0 would be $500. All right. The Y sub T, well, you tell me. If something is tripled, you multiply it by 3. If something is doubled, it's going to be a 2. If something earns 7% interest, it's going to be multiplied by what? 1 point, not 7, but 0.7, right? Okay. And how many years are we doing this for? What's the T? 14 years, right? So we just need to find out first from our calculator, what is 1.07 to the 14th power? Whatever that is, we'll multiply by 500 and we got our answer. Okay, so let's try it. So 1.07, and then we're going to use our x to the y power and go 14 equals, doink, there we go. Okay. All right, now we're going to multiply this, multiplied by $500. And there is his amount. $1,289.27, let's say. So that's his total now. So after 14 years, he has more than doubled his money. It used to be 500. He hasn't touched it. Okay. All right. So how much money did he have? How much interest did he earn? Well, obviously, you're going to take away 500 and just get $789.27. Boom. There you go. Okay. So get that formula down. Just look at the book 100 times in your notes and just copy it and use it for every single one. Eventually, it'll kind of burn its way into your head. Okay, like a tick. All right. Let's look at these oldies here before we go on. We're going to graph some exponential functions. And we know these from past experience, right? So f of x or y equals x squared looks like this, right? Ugh. Looks like kind of like that. All right. X cubed looks like this, right? We go like that, you know, like kind of like that. All right. The square root function looks like this. The absolute value function looks like this. Don't forget, you know, like the kind of the v. All right, remember those? All right. Let's look at this, graphing exponential functions. Now, look in your book. Go ahead and turn in your book. We're going to do this together. And what you have basically is they are saying for you to use your graphing calculator to graph exponential functions. And if you don't have a graphing calculator, you can always use some kind of an online calculator, graphing calculator to do this. But you'll just look at on page 482 and you'll see what this looks like. It's going to look something like this. And again, if you ever go, oh no, what do? I can't figure this out. You can put something in there for y, put something in there for x, and so on. So let's just make up some points here, okay? Let's say you put 0 for x, and 1, and 2, and 3, and so on, all right? Well, let's say x is 0. Then y is going to be 2 to the 0 power, or 1. So 0 over, and it's going to be 1 up right there. If, if x is 1, then you're going to have y is 2 to the first power. So 1, I missed my thing there. Then 1 to the 2. And you can see on this graph, it's going to go like this. Now, it's never going to, x is never going to be, never going to actually touch the axis right there, because it can't actually do that, okay? Now look at 114.4. There's another one. This is y equals 1/2 to the x power, all right? And this is, again, using a graphing calculator. You're going to get a picture that looks like the picture on page 483, because the greater the number you go on the right, in other words, the greater the x, the smaller the number, because you're not multiplying by like an integer like this to get bigger and bigger, like this, what this graph looks like before. You're multiplying by a fraction. Of course, you multiply by a fraction, a half times a half times a half 3 times, that's way smaller than the half was at the beginning. So look on page 483, you're going to get very close to the x being, or the y being 0, but not quite. And never will actually be able to get there. Okay. All right, well, let's take a look at the practice problems. Use your scientific calculator to figure out what this is. 5 decimal places, so we'll just do that together. So, oh, you know what? Go ahead and pause it. Just try your calculator and do 2.5 to the 3rd power first. All right, x to the y power will be 3, and then your answer is 15.625. Okay. All right, next, 0.5 to the 0.5 power. That's interesting. Okay, so 0.5, but once you have a method, use the same method to the 0.5 power. Bam, 0.707. All right, that's the same thing as the square root, by the way. Okay, then let's try 3.14 times, or to the 1/3 power. Well, 3.14, and that was to the 1/3 power. All right, and we'll just do 0.3333 since we know that's a third. And here we go, 1.46. Okay, all right. Let's graph B. Y to the 3x. And if you have a graphing calculator, you can do that. If you don't, you can do one online and take a look at that picture, and you'll see the difference. The basic shape will be different than number 2, because you're going to see something like roughly like that. But number 2, since it's a fraction, you're going to see something going to this effect. Now, that's a terrible drawing, but you know what I mean. Okay. All right, let's take a look at C. Harriet deposited $900 at 8% interest compounded annually. All right, go ahead and pause it and try this one. Okay, and we know our equation is going to be, let's say, how about money? We'll call it money T. That's going to equal money at year 0 times y to the t power. We'll just do it that way, okay? Well, we don't know the answer to this. That's what we're looking for. We do, however, know the money at year 0. She has $900, all right? Now we're going to multiply by, okay, the multiplier is 8%, so that number there is going to be 1.08, okay? And after 12 years, it'll be to the 12th power. All right, so let's go ahead and figure that out. We have 1.08 to the 12th power, which will be, doop, there we go. And we will multiply that by 900. And her actual amount will be $22.66, and I think that was like 35 cents or something, or 36 cents, 35 cents. Okay, you would just subtract, and she's earned $13.66 and 35 cents. Okay. Okie doke. That's it for 114. You guys take care. Have a good day.